I will say next unit there will be some no calculator stuff. Alright, so starting with number 1. Anyone find that mistake? Sophia.
They combine the x squared y and the xy squared.
So this section right here.
Yeah.
That was a mistake because even though they look similar, they're not like terms. X squared y and xy squared are not the same thing. So then let's fix it. The 17x part was right and the 2y was right. So we just have to fix this part. What of that was like terms? Were like terms? Go ahead, Jasmine.
The 8 and 10 and 7 and 5.
8 and 10 and 7 and 5. So this would be 8 plus 10 and negative 7 plus 5. So we should have had 4 terms instead of just 3. So 17x plus 18x squared y minus 2xy squared plus 2y. Otis.
And we can put this in any order.
This needs to be in ABC order. So x has to come first, and then highest exponent. Okay. All right. Other questions on that one? And then number 3, ladies in the back, make sure you're paying attention. So as I mentioned last class, there are different methods to this, distributing everything, the box method, rewriting, however you want to do that, go for it. Who used the box method? A couple of us. And then did everyone else distribute everything? Yes? Okay. So we'll distribute everything, and then if you want to still see the box method, we'll go back and do that. So I'm just going to distribute and write what that is instead of rewriting. So x times x squared, what would that give us?
2x. I mean x to the power 2.
But here we also have a 1. So we have to add those exponents. X to the third.
Oh, we're adding?
Adding the exponents, yeah. Multiplying the like bases, but adding the exponents.
Oh.
And then x times x. That one would be x squared. And then x times 3 would just be 3x. And then we're multiplying the 2 to everything. So we have 2x squared, 2x, and 6. And then combine your like terms. Highest exponent goes first. So x to the third would go first. There's nothing else. We have 2 sets of x squareds. So that would become what? 3x squared. And then we have 2 sets of x's. And that would become 5x. And then our pluses. Good. Jasmine. We are. So that's what we did the first time. Guys, you may have the same question. Listen. We are multiplying originally. So we multiplied x to everything here to get these. And 2 to everything here to get these. After that, though, we're just adding, combining on terms. Right? Other questions on that? Hold on to this. Oh, I also need to pass back some stuff. And get out your review from, I believe I passed that out last class. I'm done. So let's start with this first page. You need to know these. Degree number of terms. You need to know that degree is going to be your highest exponent, and number of terms is how many pieces are there. So of these questions, look over this page. Which ones do you want to see go over, have questions about, just want to review any of those? Otis.
Can we do 11 and 12, please?
11 and 12, correct.
And then also 6.
6, 11, and 12. Okay, so for 6, we just have to write degree and number of terms. For 11 and 12, we have to put it in standard form. And then if you want to just practice your degree and number of terms on that as well, we can. So degree, look for the highest exponent on 6. What is that?
4.
4. And in your table, 4 degree is called what? Quartic. So if you just put 4, that's only going to give you partial credit. You need to tell me what degree that actually is, what name that is. How many terms do we have? 4. So in your number of terms, that would be classified as a polynomial. So if you just put there are 4 terms, that's only going to be half credit. Yes.
So, do we have to remember like constant linear constant?
Yes. Yes. So I want to say those words are also over there on the vocab wall, if you need them. Yeah, like right there. They're small though. But you can go over there if you need it. All right? Questions about 6? Right? For 11, we have to put this in standard form. So highest exponent goes first, but ABC order. So what would go first? A cubed. And then, so here we have other A's. So we've got to focus on those A's first. Jaden.
Positive 5, A squared, B squared.
So decreasing order. Next would be A squared, and then
2ab. And then negative 2b.
So if we were looking at this one, the degree of this would be what? Cubic. The highest exponent is 3, and that is a cubic function. And how many terms does this have?
4.
4, and it's a polynomial, yes. For 12, highest exponent goes first, but it has to be in ABC order.
Negative x to the third.
Negative x to the third would go first. And then
Negative 7x2.
negative 7x squared, y squared.
And then 5y to the power 3 plus 3.
Constants always go at the end. What is our degree?
Cubic.
Cubic again. Highest exponent is 3, and that is a cubic function. And how many terms do we have?
4, so polynomial.
4, so polynomial. Other questions on this page? Ivan, did you have a question on this page? No. Okay. If not, go on to the next one. Let's refresh our rules really fast, and then we'll go over any questions you want. If we are multiplying like bases together, what do we do with the exponents? Add. Add. So x to the a plus b is how we wrote that. If we are raising an exponent to another exponent, what are we doing with the exponents? Multiplying. So that would be x to the a times b. If we are dividing like bases, what are we doing with the exponents? Subtracting. So that would be x to the a minus b. And if we have a negative exponent, what do we do with it? It becomes a fraction. We flip it, and the exponent becomes positive. So 1 over x to the a. Or, if it was 1 over x to the negative a, we would make it x to the a. Vice versa. Both ways work. Alright, there are a bunch of exponent questions on this page and a couple pages. So look through those. Which ones do you see you want to go over, have questions about? Maybe you did, want to check, anything like that. Number 5. Okay. So we'll start with 5. Which one? 2. Otis? 2. Okay, so you and Ken have the same thought. So 2 and then 5. 6.
And then 10 all the way down.
Okay. So let's start with 2. We have parentheses. Can we do anything inside the parentheses? No, we don't have like bases or anything inside, so we can then look at both sets. We are multiplying. So that means we're multiplying the actual numbers, 3 and 6, and we are adding the exponents. So negative 2, if you need to, write in that the other exponents have 1. What would our new exponents for x and y become?
Negative x. And
Negative 2.
So x to the negative 1 and y to the negative 2. If we multiply 3 and 6, we would get 18. So it can't be a, it can't be c. Then these both have negative exponents. So that means they're both going to be in the denominator. So D would be our answer. Questions on that one? For 5, what would be our first step? Jaden?
It would be making timesing the negative exponent to the exponent.
Yep. Multiplying that negative 3 to the exponents inside. We have x to the 5th, y squared, z to the 8th in our numerator, and x to the negative 3, y to the negative 3 in our denominator. Otis? Go ahead. Then we have like bases, x and y. So we are subtracting, even though these are negative, we're still subtracting. So x to the 5 minus a negative 3, and y to the 2 minus a negative 3. What would those two new exponents become?
X squared and y to the negative 1.
Be careful, because this is minus minus.
Oh, 8.
8 and
5.
And the z would stay the same. So D. Questions on that one? Number 6, what would be our first step? on the outside? We could do that, but I wouldn't say to do that first. Think order of operations. What would we normally do first? Things inside the parentheses. Do we have anything in the parentheses we could do? Subtract the exponents. We have two numbers here. We could actually divide them. So this is going to be 2 minus 2, so 0, and 3 minus 4. Then we can apply the exponent. So this would be negative 2 to the third, still m to the 0, and n to the negative 3. Negative 2 to the third is going to become negative 8. M to the 0 is going to become, what's anything to the 0 power? 1. So anytime you see that, put 1 in its place, and then this would become 1 over n to the third. So if we still have m, we shouldn't. So it's not A, it's not B, which is our answer. C. Yeah. Can I see 4? 4. So we'll do 4 real fast and then do 10. For 4, we have numbers. We're going to divide them, but you're going to get a fraction or a decimal. Leave it as a fraction. 3 over 12 would simplify to be what?
4.
1/4. And then we're subtracting our exponent. So 5 minus 3, 1 minus 2. So the y is going to get moved to the denominator. X squared is going to stay in your numerator. So B. Regina.
Why is the negative 8 over
In 6, I was like, because this would all be over 1. So if I'm multiplying across, negative 8 would stay in the numerator, and then n to the third would be in the denominator. Does that make sense? All whole numbers are really over 1, you just don't see it. Right. For number 10, we have fraction exponents, but we're still going to do the same thing. We have parentheses, we can't do anything with those parentheses. So we're going to multiply 15 and 2/5 and 20 and 2/5. I'm going to write it like this. That should be a 5. What would our new exponents be, Jaden?
6 and 8.
For,
A6 and B8.
okay. For both?
Yes.
Then after that, you can just drop the parentheses. And then it becomes a combining like terms problem. But remember, you can only do this if your variables have the same exponents and you have the same variables. If you end up with like A10 and A6, then you would just leave this as is. So we can actually subtract these two. So we would have 1 A to the 6, B to the 8, or just A to the 6, B to the 8. And that would be our final answer. So don't let the fraction exponents freak you out. You're doing the exact same thing. Okay, let's move on to the next page. Find questions you want to see, have questions about, want to go over, anything like that. Jasmine.
Number
8. Regina. 11. Okay. Any others? Lacey? 9. We got 8, 9, 11. Jasmine? 10. Any others on that page? We'll start with those. For 8, what is our operation? Subtraction. Subtracting, yes. So you can do one of two things. Either move this so you're writing it vertical. And subtract vertically, or distribute the negative to everything in the second and combine like terms. Don't do both though. Pick one or the other. So 2x squared minus x squared will give us
X squared.
x squared. 3 minus a negative 4x. Sorry, 3x
7.
minus, yes,
Yeah, plus 1.
and plus 1. And that's it. You know you're finished when you don't have like bases to combine, you don't have like terms to combine. It's in standard form, all of those things. Number 9, what operation are we doing? Addition. So here, we just have to combine like terms. You don't even have to rearrange anything. So look for like terms. 3y squared minus y squared,
2y squared.
negative 4y plus y,
Negative 3y.
and 2 minus 1.
Plus 1.
Please double check your signs. 10, we are subtracting again, but notice how this has two terms and this has 3. Not everything is going to be subtracted. So I'm still going to rearrange it. And because this doesn't have a constant, I'm going to put plus 0 at the end. So 6a squared minus 4a squared would give us
2a squared.
negative 5a minus a positive 3a.
3, 2. Negative 2.
Don't do that. Because it's negative minus
Oh.
8, negative 8a. And then for the negative 7, I'm really doing like 0 minus a negative 7. So what would that become? Not negative. Because it's minus a negative. Positive 7. You could also just distribute that negative, combine your like terms, and you would end up with the same thing. Yeah. Because it's negative minus 3, even though this is positive. Right, for perimeter, we know we're adding up all the sides or multiplying 2 times the length and adding 2 times the width. So you could do one of two things. Add these up and then add them up again. Or multiply this by 2, and then add those up. How you do that does not matter. It just has to get done one way or the other. So I'm going to multiply this by 2 and multiply this by 2. And then I'm going to add those two end products and results together. Jaden.
Wasn't there like a polish method too?
Not for this one, because you're not multiplying.
Oh,
If it said area, then definitely yes. So 4x squared minus 10x plus 2. 2x squared plus 4x plus 6. And then let's add those together. 4x squared and 2x squared will give us 6. Negative 10 plus 4 will give us a negative 6. This is a positive. You just can't really see it. So 2 plus 6 will give us 8. So our perimeter would be that equation. If we knew what x was, we could like actually find the answer, but we don't need that. Jada.
What's the other one?
Adding them up twice. So here I listed out this and then this again because you have to remember that there are 4 sides. So then if I added up all of my like terms, that would be 2, 3, 5, 6. And then combine all of your x's. That would be negative 3, negative 8, negative 6, and then 1 plus 3 is 4, plus 1 is 5, plus 3 is 2. So either way. All right, other questions on that page? I'll say the next 2 are similar to what we just did, but different questions. But look through either of those, see if you have any other last-minute questions. Regina? 15 on the last page, on the first page. This one. Yeah. 15, you said? Right. On which page? Okay, so these will be the last ones. Did you have a question too? 1 on this page? Yes. So these will be the last ones we do, and then you'll have time to take your quiz. So we don't want to take away too much more time. For number 1, if we're simplifying this, we don't have any exponents, and we're subtracting. So what would that become? Negative 280. For 10, think about your order of operations. Here we are multiplying. We're raising exponents to another exponent. At the end, we're subtracting. Don't do anything with the subtracting part until the end. Change this part. So the first part will stay the same. The second part would become x squared y to the 6. Then we're multiplying like bases. So we have negative 2 x squared y to the 10th. Now we're subtracting. Do we have like terms? both have x squared, these both have y to the 10th. I can combine the coefficient. Questions on that one?
How would you get y to the power
6.
Oh,
Is that the one you're talking about?
yeah.
You multiply 3. For 13, look for parentheses, look for exponents. Deal with this exponent. If you want to combine your denominator at the same time, you can do that. So this would be negative 3. Notice that this is an even power, so use parentheses. I think that's a 6. So we multiplied our exponents in the numerator and added them in the denominator. Negative 3 squared would be negative 9. I'm sorry, positive 9. Then we can divide the actual numbers, subtract the exponents. Simplified, what would this become? 9 over 15. And then if we're subtracting 12 minus 6, our new exponent would be 6. And because it's positive, it's going to stay in our numerator. So 3x to the 6 all over 5. And then last one. Multiply the 7 and the 3. Combine or add, in this case, subtract your exponents. What would 21 over 6 become if we simplified it? Use your calculator if you need to. Say that again.
3.5.
Put it as a fraction.
3.5.
That would be an improper fraction. A mixed fraction. Put it in as an improper. So if you put it in alpha y equals, you should be able to see what that is simplified. Yeah. 7 over 2. And then we're subtracting our exponents. Negative 5 minus 2 is b to the negative 7. So that's going to come down. Any last general questions? Anything specific on there? So always think of your order of operations first. See if you have like bases. Go from there. Start applying your rules. Go ahead and clear off your desk except for your calculator. Yeah.